A skier makes his way down a vertical slope of 88 meters. What is his speed at the bottom of the slope ignoring friction? So first we want to find our system, which we're going to use our skier and the slope. And then we want to find any forces acting on the skier. We have two forces, the normal force and gravity. The work done by the normal force is going to be 0 because it's perpendicular to the surface. We know our initial velocity is 0 because he hasn't moved yet. And we also know that our initial y position is 0. We want to find our final velocity, and our second y position is 88 meters at the bottom of the slope. Our potential energy, or U, can be found doing the mass times the gravity force and the change in y. And our G constant, or the gravitational force when you're close to the surface of the Earth, is 9.8 meters per second squared. So we're going to set our potential energy equal to the change in kinetic energy, and we're going to solve for each. The change in potential energy can be found doing the mass times the gravitational force times the final y position minus the mass times the gravitational force times the initial y position. And our change in kinetic energy can be found doing 1/2 the mass times the final velocity squared minus 1/2 the mass and the initial velocity squared. K1, or our kinetic energy, the initial is 0 because he hasn't moved yet, but we need to find our final kinetic energy. So we come over here and we're just going to solve for each of these, and our change in potential energy, we're just going to be left with the mass times the gravitational force times the final y position because our initial y position was 0, so it cancels out. Our change in kinetic energy is going to be 1/2 the mass times the final velocity squared because our initial velocity was 0 and it cancels out. So then we have mass times the gravitational force times the final y position is equal to 1/2 the mass times the final velocity squared, which is just our formula from up here. So then our masses are going to cancel and we're going to solve for the final velocity. So V2, or our final velocity, is equal to the square root of 2 times our gravitational force times the final y position. And then we just plug in our numbers. So we have the final velocity is equal to the square root of 2 times g, which is the 9.8 meters per second, times y2, which is our 88 meters, and we get our final velocity is 42 meters per second.